Hello, welcome to my next Sudoku live solve. This is a special edition because it is my first suggestion or submission from the channel. So big thanks to Marty Sears who suggested I try this puzzle of theirs. It's an older puzzle, but it didn't get a lot of attention when it first came out, and Marty has a tremendous reputation for some just really excellent puzzles. They've been featured lots of different places, including Cracking the Cryptic and other places. And they actually have one of my favorite puzzles from the past few months, Zippery When Wet. I'll try to remember to put a link in the description to that puzzle. So I'm looking forward to trying this, hopefully solving it, and seeing what happens. So this puzzle has a bunch of rules, but they're mostly standard, so we'll go over them fairly quickly. So first we've got these Kropke dots, or these black Kropke dots, which means that the digits on either side of the dot have to be in a 1-to-2 ratio. That means one is double the other. So for example, this could be a 3 and a 6. That'll be fine, and it doesn't have to be that one in particular is higher than the other. I mean, one has to be a bit higher than the other, but it doesn't matter which side the higher or lower digit goes on. We have German whisper lines, which mean that adjacent digits have to have a difference of at least 5. And just as a consequence of that, what we're going to end up seeing is that along these 3-digit lines, they kind of alternate between high digits and low digits, and 5 cannot be on the German whisper line. We have these Renman lines, which need to be non-repeating digits. You can't have the same digit twice on a Renman line. And if you took all the digits on them and sorted them by size, then they would form a consecutive set. So for example, this could be the set of digits 1 to 5, but they can be in any order, right? I could do 1, 2, 3, 4, 5. And if I sorted these digits, it would just be 1, 2, 3, 4, 5. And so that would satisfy the Renban constraint. And it doesn't have to start at 1, right? It could start anywhere. It could be 2, 3, 4, 5, 6. Oops. 6. That's fine too, right? And any set of 5 consecutive digits in any order. These yellow lines are entropic lines. So entropy kind of refers to how big the digit is. And in this case, all the lines are length 3. So the effective rule is just on each of these lines, I need one low digit from 1, 2, 3, one middle digit from 4, 5, 6, and one high digit from 7, 8, 9. So I need one of each on each of these 3 lines. And the last rule, which is the kind of only new rule that I think is in this puzzle, is this red diamond. And this red diamond is going to identify how many times that particular digit ends up on a line somewhere else in the puzzle. So for example, if this were a 4, then that would mean that there are 4 other lines, maybe it'd be these 4, where this one. So there would be 4 different places, and exactly 4 other places, 4 other lines where that digit would appear. That's what that red diamond means. So those are the rules. Again, big thank you to Marty Sears for suggesting this puzzle. I'm a little worried that I'm not going to be able to solve it on video, but I'm going to try it. So let's just get to it. So I'm just going to quickly restart here so I know how long I've been taking. Okay, so I actually set this up about a week ago, so I've kind of forgotten my initial thoughts on the puzzle. But I think these black dots are going to be really important, right? So the title of the puzzle is Mixed Doubles. These remind me of these kind of like a tennis court maybe, or a pair of tennis courts next to each other. So I think this is the key here. And the thing about black Kropke dots in particular, is that there are only 6 digits that you can put on a black Kropke dot, right? It's only 1, 2, 3, 4, 6, and 8. I can't put 5, 7, or 9 on this Kropke dot because there's no digit that's either double or half of that is one of the digits in the puzzle. So that's my limitation. So there's 6 possible digits I can put there. And because I can only put 6 digits here, I've kind of got 6 digits that can go in 4 places. And I have 6 digits that can actually go in 8 places if I think about these jointly. And if I think about these jointly, what you hopefully can see, if I say there are 8 spots, only 6 digits to fill them, that at least 2 of them have to repeat, right? At least 2 of these digits have to repeat. And if those 2 digits repeat, then where am I going to put them in the box in between them? I can't put them. So like, let's say the digits, let's say this is a 1, 2, and this is a 1, 2, right? So the digits 1 and 2 repeat on these 2 black dots. Well, where do 1 and 2 go in this box? They can't go here, right? Because one of my digits is up here, one of my digits is down here. You know, they might be reversed. It might, you know, I could end up with 1, 2, 4, 8, 2. What's going to be 4? I guess I can't have 2 and 4 repeating here. So I didn't realize that, but is that true? I can't have 2, 4 repeat. No, I could have 2, 4. No. Well. So let me just explain what I was trying to do in a different way. So let's say I had 1, 2. Let's do it down here actually. So because these are actually tilted different ways, so there's like a different way that they can do. So if this is 1, 2, and this is 2, 4, right? And this is 3, 6, and this is 4, 8. Okay, so I have 2 repeating digits. 1 and 2 are still, I have 2 and 4 repeating, right? And even though it's not like up here where they have to be kind of these dominoes, right? I have 2, 4 down here and 2, 4 over here. Whatever the case, wherever the 2 is, it's got to be in the other row, in the other box. And so the final 2 has to go kind of in the 3rd row that's not taken up by that digit in the Kropke squares. Same with the 4. So these 2 digits can't go in between those Kropke dots. They've got to go down here. So in this case, I would need both a 2 and a 4, like this, on this line. And so maybe we'll start down here. So that's interesting because these lines, that's going to be true of these on these Ren bands, right? It's going to be true of these on this German Whisper. These lines are going to have different restrictions that hopefully will kind of tell us something about what digits can repeat here. So I'm thinking about what digits can repeat on here. And the first thing I'm thinking is that I can't put a 1 in both of these boxes on the Kropke dots, on these Kropke squares. Why not? Suppose I did, right? Well, first of all, this one, it just doesn't work because if I have 1, 2 here, where can I put a 1 down here? Well, I'm going to have to put it down here, right? And then where do I put a 2? It's got to go across the Kropke dot from the 1. It's not where do I put the 2. It's if I have a 1 on this Kropke dot, the 2 is going to have to go across from it. So I'm going to have to put a 2 in one of these cells, but that will break this line. So I can't put a 1. I can put a 1 on one of these 4 Kropke dots, but not on both. Because if I put a 1 in one place, if I put in the second one, that will end up breaking the 2s. So I can't have a repeated 1 on this line. And in fact, that's going to work for any digit that has a forced pair, right? So if this is a 3, say, if that's a 3, then that's going to go with a 6. If I want to repeat the 3, it's got to go down here, but that's going to pair with a 6 up here, which will break the line again. So any digit that is forced, that only has one kind of Kropke dot partner, can't be repeated here. And the only numbers that don't have a Kropke dot partner are 2 and 4. So 2 and 4 are the repeated digits down here, which means these cells both have a 2 and a 4. And I think it means exactly one of these dots is a 2-4 pair, but let me just think through the logic on that. So they're either 0, 1, or 2, right? So let's say they're a 0. If there are 0, 2, 4 pairs, that means that 2 and 4 are not 2 and 4 are on different rows over here, which means 2 and 4 are on different rows over here, which means they're on different. And we assume 0 Kropke 2, 4 pairs, so so 2 and 4 are not going to. The row thing doesn't even matter. If I have 2 and 4 that are not on the same Kropke dot, those 2s and 4s are going to be paired with 1s and 8s. I can't have a 3, 6 somewhere because both dots, one of the dots in each square is taken up by a 2. one of the dots has a 4, so I can't have a 3, 6 pair in other dots. So if there's 0, 2, 4 pairs, then I can't have a 3, 6 on either. Both of these are going to be 1, 2, 4, 8. That means I'm going to have 1, 2, 4, 8 all have to go on this line. They won't fit. So I can't have exactly 0, 2, 4 pairs. Can I have exactly 2? So no, I can't have 2 pairs for the exact same reason that I couldn't have a pair of 3, 6s, right? So if this were a 2, 4 pair, where does my 2, 4 pair go here? Not here, because this cell can't be either 2 or 4. This cell can't be either 2 or 4. And so neither of these could be a 2, 4 pair. So there's going to be exactly one 2, 4 Kropke dot here somewhere. Not that that's helpful yet. Maybe it'll never be helpful. Okay, so now thinking about this line, I've got my low digit, a 2, my middle digit, a 4. So the only thing left is a high digit. It's either 7, 8, or 9, but I don't know which yet. I'm tempted to say it can't be 8 because I can't have an 8 doubled here, but I can have an 8 here even if it's not doubled down here in the Kropke dots, right? I could have an 8 here, a 4, 8 pair here, and then, a 2, 4 pair here with a 3, 6 pair, right? And that 4, 8, that could be 1, 2. So that would work. I could have 8 in exactly one of these, and then, over here somewhere. That would be fine. So I think that's all I can say. I mean, I'm noticing that there has to be a 4 on this run band, and it can't go in this box. So there's a 4 here. I don't want to mark it because it crosses the box, but I'm going to try to keep that in the back of my mind that I've got this limitation on 4s in row 6. So let's try the run bands. So what's nice, I know that there's a 2 and a 4 in these, and that might help think about what repeats here. So can I do the same trick? So these face different ways. So actually, these run bands might end up with a different restriction on them because here I've got these 2 Kropke dots face these 2 in a sense, in a way that these are kind of all parallel. So we might end up with something different. So let's. I'm going to try to think about what's universal, so I can do both sides at a time, and then I'll maybe get into what's different about them. So the first thing I'm noticing is that I can't repeat 8s or 6s in any of in like across the verticals, right? I can't repeat 8 here. I mean, maybe I can repeat 8 this way, but I have to think about that. So, but I can't repeat 8s in these vertical Kropke dots. Why? So if I remember, 8 can only pair with 4. So if I have an 8 in this one, then there's a 4. Well, I know there's a 4 here as well, but there's an 8 here, there's an 8, 4 pair in this Kropke square. There's a second 8 here, which we're assuming, what if I put 2 8s here? Then there's also going to be 4 up here. So my repeated digits, at least, are going to be 8 and 4, which means I need an 8 and a 4 in this run band, but this run band just isn't long enough to go from 4 to 8. Or to go from 4 to 8, I would need 5 digits, 4, 5, 6, 7, 8. So I would need at least a length 5 run band. So I can't have 4 and 8 here. So I can't repeat 8 because 8 would necessarily repeat 4. And I can't have 8 and 4 here. So 8 doesn't repeat on these. Same exact reason 6 doesn't repeat on these, right? So 6 doesn't repeat on these because if 6 repeats, 3 repeats. I can't have 6 and 3. I need at least a length 4, 3, 4, 5, 6 to make that run band work. So I can't have 6 repeat. If I can't have 6 repeat, it means I can't have 3 repeat. So the repeating digits are 1, 2, and from 1, 2, and 4. It can't be 1, 4 because, again, I would need 1, 2, 3, 4 on this line. So 2 definitely repeats. So I actually end up with a 2 in all 4 squares and 2 on this. And now let's think for a second. If I have 2, 4 repeating, then this is 2 and 4, and these 2, 4 will be in the run band. I'll need a 3 to repeat. So if it's 2, 4 repeating, this is 2, 3, 4. Same thing goes over here. If this is 2, 1 repeating, then this is 1, 2, 3. Same thing over here. So actually, both of these have a 2 and a 3 on it, and then either a 1 or a 4 as the missing part of the run band. It's either 2, 3, 4 or 1, 2, 3 in both cases. Okay. Can it be 1, 2? So here I think that's fine, right? I could have 1, 2, right? 1, 2. That wouldn't break the Ren bands. But on the other side, I think that's not right. Right? What if I put 1, 2 down here? And now I'm in this situation where I can't have the same pair over here. Right? So let me try to reframe that because it's a little sloppy. Can I repeat ones in these dots? I think the answer is no. Right? Suppose I do. That means I have a 1 down here and a 1 down here. So if I have a 1 down here, let's say it doesn't matter where I put it. Let's say I put it here. The 1 has to pair with 2. And then where does 1 go up here? Well, it's going to have to go in one of these 2 spots. And then the 1 will have to pair with a 2, and then that 2 will be in the same column as here. And so that'll just break the column. So I can't have 1 repeated here for the same reason I couldn't have, 8s, 6s, 3s, 1s repeated down here. So there's actually, so this is the 2, 3, 4, because 2 and 4 will be repeated over here. I wonder if it's just going to be 2 4s all the way around. Yeah, okay, 2, 4, 9, that'd be fine. So this is actually a 2, 3, 4 Ren band. Okay, so that's pretty good. So actually, I was thinking about this and with this entropic line and this, and but they're in different spots. So I think that actually is fine. I was thinking if these were, well, it doesn't matter because 1 can go in here. Sorry, my brain misfired. So ignore all of that. Let's just keep going. Let's see what happens with German Whisper. So again, I know there's a 2 repeated, so there's going to be a 2 up here. Can I do 8s? No, I can't have 8 repeated because if I have 8 repeated, I also have 4 repeated. And so this would be 2, 4, 8. But I can't make a German Whisper work with 2, 4, 8 because, well, again, we have to alternate high and low. So this would be an 8. I'd have 2 and 4 on the sides of it, but 8 can't be adjacent to 4 because they only have a difference of 4. So there's not a repeated 8 in these sections. So it's not 2, 4, 8. And I don't think, there's not a repeated 6 either. So there's a 2 on the line. If there were repeated, that works both ways. I can't have repeated 3 or repeated 6. I can't have repeated 3 or repeated 6 because if I do, then I get the other one. So this becomes a 2, 3, 6 line. And that's not going to work with the German Whisper. Again, I need a 6 here. It's even worse than 8. 6 can't go with 2 or 3. So there's not a repeated 6 either. So the other repeat digit, what is left, is either 1 or 4, which is another low digit at least. So now I know that there are 2 repeated low digits on this German Whisper. If there are 2 low digits, they've got to go on the outsides because we have to alternate low, high, low. I can't go high, low, high and still put 2 low digits here. So the other digit's either 1 or 4. And then this is going to be something from 7, 8, 9. Okay. So what now? I'm thinking, so there's no 2 on this Ren band because 2 is one of these spots, so it's not here. 2 is on there, so it's not here. So there's no 2 on the Ren band. So this is, the smallest this could be is 3, 4, 5, 6, 7. The highest it could be is 5, 6, 7, 8, 9. So either way, there's 5, 6, and 7 on the Ren band. From before, I said these are 4, so I'm going to get rid of these 4s. Those can't be 4 because 4 has to be here on this Ren band. Back to here. This has to have 5, 6, and 7. And then either 3, 4, 8, 9. I don't see immediately why. Well, what I'm noticing is I can't put 3 and 4 here because then I would need 2. I need a low digit for this one of these 2 cells in the German Whisper. So there's either one. Hold on. I mean, the reason I said 3, 4 is because I already know 1 and 2 aren't on here. So 3 and 4, I mean, I could have one of them here and one of them here. That would be fine. But I can't have both 3 and 4 here. That would make this 1, 2, 3, 4. I wouldn't have a low digit to put on this pair. That's too complicated. Let me see if there's something. I don't even know what I would mark to put that, to show that. Okay, is that true? No, it's not true. I almost said I can't have 2 4s in either of these doublets, but that's not true. Right? I can have 2 4, 3 6. Oh no, that is true. Yeah, I can't have 2 4 on any of these. On any of these. So the 2 and the 4. Hold on, is that right? I can't have 2 4. I can't have 2 4 in different doubles. Suppose I did, right? Suppose I have 2 4 here. Now what do I put here? I can't do 1 2 or 4 8, so it's got to be a 3 6 pair. Now what do I put over here? 3 and 6 can't repeat, right? 3 and 6 can't repeat. So I need 1 2 4 8. But I need 2 4 have to go down here, and then 1 8 would go up here. So that's going to break. So I can't have 2 4 on a double like that in either place. And so this 2 and this 4 are on different Ren bands. So this 2 is going to go with a 1, and the 4 is going to go with an 8. And since I can't have 1 2 4 8 repeating all up here, then this is going to be 2 with either 4 or 1. And then 3 and 6 are definitely going to be on here. Okay. But 3 doesn't repeat here, right? We said that because we said if 3 repeats, 6 repeats, and 6 is not on here. So we can't have a 3 6 down here. So this is also 1 2 4 8. And then I can't have that repeating here. So so one of these is a 2 4. And the other one is a 3 6. And so it's either this is 2 4 or this is 2 4. And then the other one's 1 8. Okay. I don't know if that's anything. So the missing digit here is 1 or 4. Okay. There's got to be something else. What about this? And what would this here? So if this is 8, that's going to pair with 1 because 2, 3, 4 are taken. If this is low, I mean, this could be anything. What about this? These Ren bands can't be too low. 4 5 is the lowest it could be. But it could be 4 5. And it could be 7 8 9. 7 8 or 8 9. Yeah, not sure. Not sure. Hold on. I'm having a thought, but does it have to do with, so I think there's going to be some, I call it windmilling. I don't know if there's a real name for it. There's a puzzle a while ago. I think it was called Windmills that had this feature. I've seen it quite frequently, where, yeah. So this idea of windmilling is if I have digits that like can't go, because these digits are pretty well filled out. I kind of know what's in here. So if I have a digit that's can't be in any of these boxes, so for example 5, 7, and 9, because they can't go on crappy dots. Where do they go in the boxes? Well, they're going to go on the outside of these cells always. Right? 5, 7, 9 are for sure going to go in these places. But interestingly, they can't go in the corner. So why can't they go in the corner? Suppose I did. Suppose I put a 5 there, and the logic will repeat no matter which number I choose. If I put a 5 here, then that means 5 can't go in any of those spots. So I'm going to delete all these markings to show you. So if that's 5, where do I put 5 in box 1? Well, it's got to go in one of those 2 spots. That's all that's left. Where does it go in box 9? It's got to go in one of those 2 spots. That's all that's left. Now where does it go here? It can't go anywhere because wherever I put it, it's either going to break this box if I put it in any of those spots. If I put any of those spots, it's going to break this box. So there's no place left to put the 5 when I get around. So the way I think about it is there are these kind of either counterclockwise, like windmill veins. I don't know what you call them. counterclockwise or clockwise. And if I put a digit that can't go in any of these boxes, like 5, 7, or 9, in one of these spots, it's going to propagate kind of around this wheel. So 5, 7, 9 can't go here. So 5, 7, 9 are in these spots. And I think that actually means it can't go here, right? So is that right? If suppose this is 7. Yeah, I think it's the exact same problem. If this is 7, then I get 7 in both of those spots, and then 7 in both of those spots, but that's going to break the bottom row. So yeah, I can't have 7, 8, or 9 in the like. You can think of 5. You can think of these corner marks as kind of being exhaustive of the row as well. 5, 7, and 9 have to go in these spots. So that's not 7 or 9. That's in fact 8, which means that's not 4, which means 1 repeats. So these aren't 4. That's 1. I'm going to get rid of. Make these all essential marks. 1 repeats here, so that's not 8. Oh no, that is 8. It's 1. The 1 repeats here. Okay, and the 4 doesn't. Okay. So then what goes here? So what goes in the corners are something that's missing from the crop keyed out. So that's 4, 8, but not 8. So that's 4. And this is 3 or 6. 3 would go with 8. 6 would go with 1. So it's not 2 or 4 here. And before, remember, we said one of these is a 1, 8, one is a 2, 4. So that's the 1, 8. And this is the 2, 4. Or, 1 will pair with 2, 8 will pair with 4. I guess I wouldn't necessarily go which way around this is. But that is going to tell me that how those go. So now, okay, what do I do with 8s? Well, I could put an 8 here, I guess. So can I be having, so let's think more about this run band line. If it's 3, 4, 5, 6, 7, no, now this can't be 3 or 4. So only one, and we said before we can't have both 3 and 4 in here. This is neither. So I can't have 3, 4 in here. I also can't have 3, 4 both here. So one of them's in here, one's in here. But I can't have 3 here with 4 here. Why not? Because if I put 3 here, 4 has to go on the run band. And where's it going to go? Right? So in fact, the 4 is in here, and the 3 is over here. And so the 3 is going to have to get paired with a 9. So neither of these are 9. This is not the 3, 6 pair. So this is not the 1, 2 pair. This 1, 2 tells me how these go. This 1 tells me that's the 6. Or I should have seen that before. This is 2, 3, 4, so that's not 3. What's left? So there's a 3 missing in something like this. And so I'm going to get a kind of windmilling around here too of the like extra digit. Right? So 3 of these digits are windmilling around these crop key dots. And there's going to be one spot that's going to be reserved for whatever's missing from kind of this, so like 8, for example, in this set. And that is going to have to propagate on the same side, right? So if, let's say this is 3 up here, then 8's going to have to go down here. Why? Because if 3's up here, then I get 1 of 5, 7, 9 up here, but the other 2 are down here, which means I get these 2 5, 7, 9s up here, and then 8's going to be down here. And I actually see, so the one that's missing is this 8. So one of these is 8. And in fact, I know it's here because this Ren band needs an even number, so I can't have 5, 7, 9 on both sides. So the 8 is there. I'm going to trade these for essential marks because it's exhausting the cells now. Right, and so I know that, just where's the 3 in this row? It's got to be one of those spots. Okay, this is 1 or 8. I actually don't know which one that is. This is 3 or 6. I don't know which way that goes. 3 could go with 8, 6 could go with 1. So that's not 2 or 4. So that is, and then I don't know which way around those go. I don't get the same thing I get here, right? Because these don't point at it. Yeah. Okay, so I don't know which way around those go. Something like this. So what's missing is either 3. So the other 3 or 6 goes in here. Oops. Because it's this way around, right? And then the other 1 or 8 goes around here. Again, I need an even number on this Ren band, so that has to be the 8. I'm going to trade these for corner marks again. That's 7 or 9. That's my 1. Do I know which way that goes yet? Still no, right? Oh, 4. Yeah, 4 means that is 1, 2, 3. And now where does my low digit go on this entropy line? It has to go here because it can't go in either of those cells because in the box they're taken. What goes here? Not 4, 5, 7, or 9. And so this is 4, 5, 6, 7, 8 in some order. So it can't have a 9 on it. And the 8 is going to go down here because it can't go on this. It can't go in this box because of this 8. So we'll go, what's left? 5, 6, 7. And the 6 has, oh, did I break it? Oh no. I just must have mismarked this. Hold on. Yeah. Sorry, let me back up one step. First, I said 5, 7, 9, I thought this was 3, 6 or something. This is actually a 3, 5, 7. This actually has to be 6 by just, Sudoku row logic. The 8 still works down here, and now what's left here is 4, 5, 7, making this a 9, which means 9s are going to propagate on the counterclockwise side of this windmill. And it's just 5, 7, or 9. 3, 6 means that's not 3, so that's the 3. 6 is going to go in one of these. Don't know which. Okay, what's left here? 5, 7, 9, and 1. So one of these is a 1. The other one's 5, 7, 9. But this can't be 5. What goes here? 3 could go with 8, 9. 3 would have to go with 9. These can't be 7, 9 for the reason before. So it's actually a 2, 4, 8 triple. Right, so these can't be 7 or 9 because of this windmill thing. The same reason that we can have 7, 9 up here. If I have a 7 or 9 here, then they would go in those spots in the corner boxes. They have to go in here, right? And then they'd see each other. So this is a 2, 4, 8 triple. We said before that 4 goes in one of these spots. Okay, that means, so this is a high digit. So why is this a high digit? I know from before, so we'll repeat again. 4 is in this box, so it's not on the Ren band here, but it has to be on this Ren band because it's size 6. So 4, 5, and 6 all have to be on the Ren band. Like the smallest Ren band can be is 1 to 6. That would include a 4. The highest the Ren band can be is 4 to 9. That also includes a 4. So 4 is on here, not in the box. So it's one of these. So that's 4. I kind of know where 3 of the 1, 2, 3 low digits are. There's one here, there's one here, and there's one somewhere in this entropic line. I don't know exactly where yet, but somewhere here. Not here actually, because I see 1, 3, 2, 4. In fact, this means 5 and 6 have to be here, so not here. Okay, and then 7 or 9 and something. So 1, 2, 3 is in one of those spots. So 1, 2, 3, 4 are kind of accounted for here. So the low digit can't go here. So it has to be a high digit. So this is low. It can't be 2 or 4 because they're already taken in the box. And then this again is high. Can't be 6 because of this 6. Can't be 8 because of the box. So now I've got a 5, 7, 9 triple. That makes this, can this be 1? This is 1, 2, and 4 would have to go here. That would break. Yeah, so I can't have 1 on the Ren band. So 1 is going to go in one of these spots. So 1's not on the Ren band. 2's not on the Ren band, right? 1, 2, 3 are taken up here. So there's no 2 on the Ren band. So it's 3, 4, 5, 6, 7, 8. So it's 3 to 8 or 4 to 9. So either way, 4 to 8 are definitely on this Ren band. 8 and 4 are down here. So these two have 4 and 8 in them. And then what's left? I need a 5 and a 7 somewhere. They could easily go in here. Or I could put 1 here. And then 3 or 8. No, it's 3 or 9. I can't put 3 here, but I could put 3 here. Can I put 3 here? If 3 is down here, And that's 1. 4 is up here. I get 7, 9. No, that's fine. Okay. Yeah, I can't see a reason that doesn't work. What goes here? Either any low digit or almost anything. What do you think about this? I've been dreading thinking about how to do this rule because this is not the kind of logic I'm particularly good at. But let's just try counting. So what can go in here? So remember this, the rule for the red diamond is this digit will tell you how many times that digit will appear on a line clue. So can this be 1? No, because I've got a 1 here and a 1 here. That's at least 2 1s. So I can't have a 1. Can it be 2? 1, 2. I suppose it could be 2. Okay, so it could be 2, right? Is there any reason it can't be 2? I don't see it. 3, 1, 2, 3. This doesn't have to be. This doesn't have to be. I don't need to have a 3 on the red, but I could put a 3 here, right? And then a 3 here. That would be fine. So 3 works. Well, 4. 4. Let's see. 1, 2, 3, and then 4. Yeah. In fact, almost surely there are. Not almost surely. Well, I don't put it this way. If there's a 4 here, well, I guess you could fit a 5th one here. Well, no. Yes. How do I say this? If this is a 4, then there are 4 4s on red bands. There'll be 1 here, not middle, 1 here, 1 here, and then there'll be 1 either here. There will just be 1 there. But I mean, that doesn't have to be true. But if there's a 4 here, there will be 4 on the red bands. About 5. 1, 2, 3, 4. Well, I'm going to those. 4. I think the most I can get is 4. So it can't be 5. What, 6? 1, 2, 3, 4, 5, 6. Yep, I can get 6, 7. I think now we're getting too big, right? So let's try to think the other way. If there are at least 3 7s in boxes that aren't on lines, then this won't work. And I can find 1, 2, and if there's 1 in the middle, that'll be the 3rd. So it can't be 7. 8, I need to find 2, but 1's already here in the middle. Here's 2, so it can't be 8. Same with 9. I mean, 9 just self-evidently can't be there because there's 1 already not on a line because it's on the diamond. It can't be 9. Okay, so that's a lot of choices actually. Is there some reason it can't? Yeah, okay. So I was thinking, is there something I could restrict this at a different dimension? For example, could it not be low for some reason? In fact, it can't be low. Why can't it be low? Well, I've got all 4 lows accounted for in this row, right? I've got 1 here, 1 here, 1 here, in one of those. I don't know which spot, but that German whisperer is going to have a low digit in one of those 2 cells. Same thing over here. So 1, 2, 3, 4 low digits accounted for in the row. That's got to be 6. And then this has to be high or 5, I guess. Same thing, otherwise it's not 6. But now I know that there are exactly 6 on line. So I think that's going to tell me, so there are exactly 3 that aren't on lines. There's 1, there's 2, there's 3. So every other box has to have a 6 on a line. So there's 1, there's 1. Where's the 1 in this box? It's got to be here. Where's the 1 in this box? It's got to be one of those 2. Where's the 1 in this box? It's got to be here. Where's the 1 in this box? It's got to be here. That places it there. So I'm going to unhighlight these and just say those all have to be 6. And then those are 6. And one of those is 6. And that's almost finishing our 6s. Okay, that's cool. Okay, what next? What is this? It's either 1, 2, 3, 7, 8, 9. Okay, I don't see why. Hold on. That's not 6. This can't be 3 because I end up with 3, 9. That breaks this. So that's 1. Oops, 1. So this is not 1. So 1 is here with 2. That's a 4, 8 pair. That means this is 2, 4. That's 3. And then 5, 7, 9. Yeah, I can't do anything with that. And that's not 6, so that's 3. In fact, let's do that. 1, 2, 3, 6. What's this? Do I know which way these go? Because that would tell me something about this. Not obviously. What about here? We have 4 here. Oh, where does 5 go in this row? Where does 5 go in this row? Because it can't go on this entropic line because I've already got my middle digit in the 6. That's not 5, that's not 5, that's not 5. So my 5's here. Like I said, my 4 is here because of there has to be 4 on this Ren band. It's not in this box. So there's a 4 here, there's a 5 here, and an 8, right? Because this has to have an 8. Because why does it have to have an 8? It can't have a 2. So it has to be at least 3, 4, 5, 6, 7, 8. So it has to have an 8, and it can't be down here. So these are 4, 5, 8. It's 4, 5, 8, which means this has to have a 7. Oops, which makes that a 9. And then the other one is either 3 or 9. Not 9. Wait. Yeah, not 9 because of that 9. So that's just 3, 7 filling out. And that makes this a 5, which I could have known before because the 5 was on the Ren band. So it can't be the Ren band here or the German Whisperer. So that's the 5. That's not 5. And 5 goes here in box 5 because it's not here. It's not here by Sudoku, not here by German Whispers, not here by the entropic line. It can't be paired with a 6. So that's a 5, which makes that the 5. I still can't figure out which way this goes. So 3, 7. This is a 3, 7, 9 pair, triple rather. So hold on, I've got too many digits. 8 means that's not 8. So that's 2 or 4, which means that's low. So that's high. That's low. That's not 3. Here's a 1, 2 pair, so that's not 2. Here's 4, 5, 8. This can't be 5. That can be 4 pair. That's the 5. Does that work? Did I break it? Oh geez, hold on. I think I broke the puzzle because I don't think I'm going to be able to disambiguate this. I don't think, right? There's no way. So I made a mistake. So let me just back up a second. I think I just missed. Hold on. Let me back up to here. In fact, this can't be 5 because of this 5. So I pencil marked something wrong. Hold on. That can't be 2. 1, 2. This is not 4, 8. It's 4, 7, 8. 5. It's not there. 4, 8. No, 4, 7, 8. Hold on. What is this cell? This 4, 8 done. That makes this 7. This 4. 1, 2, 3, 4, 5, 6, 7. That's a 9. Oh my god, sorry. That's just a 9 naked. 7. That's not 7. Let's see. One of these is a 3. I don't know which, right? No, I know it's because this isn't a 3 because I can't go with 7. So that's not 3. That is 7, 3. That's going to go with 9 because the load is already taken by the 3. That makes this a 1. Only place in the box it can go. And that makes this 8. It's got to be high. 4, 2, 1. This has to be low. So it's 4 because 1, 2, 3 are taken here. Those aren't 4. 7 and 9 are going in there. 3, 4 are here, so that's 2. That's 1. 4. This 4 makes this 3, 4 makes this 3, 2. There's too many digits here. What's 9 is missing, so that's 7. That's 5. That is 7. That 7 makes this 9. This 4 makes 8, 4. 5, 8. 5 makes that 7. 5. 3, 5. 5s. Yeah, we're like, I'm just basically doing cleanup, I think, at this point. 3, 5, 3, 6, 9, 6, 2, 1, 8, 2, 4, 7, 9, 9, 7. Got that? 2, 1. I think I did it. Let me check. Hey, we did it. Great. Thank you so much, Marty Sears, for suggesting this puzzle. Yeah, done a lot of cleanup at the end, but the beginning was very, very cool. I was not, was not expecting any of that. It's just a really fun puzzle, and I'm very happy to have done it. So thank you for recommending it. If you or anyone else has other puzzles they would like me to take a stab at, happy to give it a try. Can't promise I will succeed, but I'll do my best. So thank you very much. Thank you for watching. Have a great